In January 2024, I aced my CCN exam in a single attempt, and it's been a while since I thoroughly revised the CCNA syllabus. So, in this video, I am going to do so. And I love to hear the classical music or the slightly classical lofi bits while studying. And here is the mention of a very good and very lovely channel called Classical Music but Lofi. And the guy says that if you want to use my videos in if you want to use his music in our video, we have to tag him. So I'm going to tag him in the comment section, and this is the start classical music. But and in just uh, one day ago, he already released a track which we are going to play in the background. And this is not going to be a narrative video. I'm just going to study my syllabus using the website called freeccnastudyguide.com. It is one of the resources that helped me passing my CCNA exam, acing my CCNA exam, that I love to say, in a single try. These websites covers all these syllabus which you can find the study guides, and here is whole of CCNA divided into 14 chapters, I think 14 chapters. So we will go through each chapter, pick the keywords which I'm going to enter it here in a read.md, a markdown file, which we going to format it using the help of ChatGPT, which will further assist it to improve the uh, point taking or note taking rhythm. So starting from the start, once again I'm going to tell you that this is not going to be a narrative video. I'm just going to study thoroughly with each chapters one by one, picking out the key terms because that's how I study. So let's begin. Thank you for being part of this journey. Begin with some classical beats. Introduction to network. Before you It will be a cumbersome task to consolidate all the reports. Consolidation is a fancy word that I love, so I'm going to paste it here. I want to make sure that the words that I'm pasting here should be visible to you. Consolidate. Interconnection. Centralized. Cost, time, effort. Resource optimization. Network interface card, a card that comes with computer or sometimes baked into the motherboard that helps a computer to connect with another computer in the network. It may be wireless, your Wi-Fi card. One of the internet comes to the another cable. They host our network. Network is effective. It will not be without a separate NIC. Actually, this is saying that if you have more than two hosts, then the network interface usually has a single port and is not able to connect with multiple hosts at a time. So we need to use a network device that is called a hub. A hub is a dumb form of device that is used to connect with multiple networks. For example, here A, B and C are connected using hub. Then we are going to divide the network into unicast, broadcast, or multicast. The word uni means one, a connection between one to another, or the communication between one guy to another guy, a girl, is known as unicast. Broadcast means shouting of message, and multicast means only the subscriber of the message can hear the message, not everyone. A hub simply repeats the information from one host to another. Okay. A hub creates a shared network medium where only a single host can send packet at a time. The sending of packet at a time, which we also differentiate between the multiple times, such as when packet is sent between from one host to another at a single time, or in the scenario where the communication both parties can send with each other, and in the scenario when both parties can send data with each other but at the same time. We also got to divide. We used to devise this form of communication as simplex, duplex, full duplex, and half duplex. I'm sure that I'm going to see that in the upcoming chapter. So let's continue. The shared network medium is called single collision domain. I want to take my spin over the word collision domain. Actually, it's a very interesting and confusing word that often beginners don't understand. The collision domain is simply the pathway or the communication channel that a device takes in order to communicate with another one. For example, I am communicating with my camera or my microphone here. It is a channel, and this channel is called collision domain. What does it differentiate? There's also another domain called broadcast domains. Let me write it. If we know the collision domain, then what the hell is broadcast domain? The broadcast domain is also a pathway, but it is a pathway that I take when I want to reach my message to every other guy present in the room or the stadium or the hall. So broadcast domain, we have to pass a specific form of message that announces to everyone present in the room. It's not just whispering, it must be louder enough. So there's a different kind of message that we call broadcast message, and I'm sure we will see here the problems associated with hub that can use several degradation of network. To overcome, switches are used instead of hub. So in very layman term, actually the hub announces each messages. Suppose if this is a hub, message sent via A to B will be transversed to C. But as it is switch, it is smart enough to send a message and differentiate that the A is shouting or A is whispering. Actually, the differentiation between whispering and shouting is the differentiation between collision and broadcast. Broadcast is shouting while the collision is whispering, means sharing one to another. And if we are using a third party device, third party in the sense another network device that bridges the connection between multiple computers, then the differentiation of whispering and broadcasting becomes more prominent. Continuing with it, here we can see network, the collision domain 2. Actually, we are getting a question. So you can figure out how many collision domain exist in them. The collision domain is the whispering. So how many devices can whisper without letting any other device hear them. So let's begin by finding the answer ourselves. And this is the pen that I'm going to use in order to find the answer. So actually the first collision domain between host B and C. The second collision domain will become between A and B. The third will become A and C. And these both devices come in same collision domain. So actually there's not a collision domain. So let's see what is the answer here. If you answered 5 for the figure 1 to 4, what we answered I forgot. The first, the second, the third, and these are in the same collision domain as these are connected by a hub. One, two, three, four, and 5. Actually, what we can see or say that the connection output by switch can be termed as collision domain. It's 1, it's 2, it's 3, it's 4, and it's 5. Moving with, let's see, it's 1, it's 2, it's 3, it's 4, it's 5, it's 6, and it's 7. Figure 7 has 7 collision domain. So here I can write my own definition. Coming out of which all hosts connected to a switch network said to be in the same broadcast domain. So broadcast domain, actually the switch, as I've already told you enough, that the switch differentiate between shouting and whispering of the message. So the every device connected to a switch can hear the shouting of a device, but not the whispering one. So all hosts connected to a switch network are said to be in broadcast domain. That's a good point, so I'm going to note it here. These separate networks are interconnected using routers. Now this is the time where I can become an hero. How so? So see, there's a router. A router stands that these are different networks. Network 1, this is different network. Network 2, and this is a third network. Network third. Now let's see how many collision domains are there. So in network third, there are 1, 2, and 3 collision domain. Here is also 3, and here is also 3 collision domain. Now if this computer A, wants to talk to computer B, it will first pass its traffic to switch, then switch will out via this port, and router decide whether to pass or not pass this traffic. And if it passes the traffic, then the traffic comes to here, and finally the traffic will transfer to B. If router shouts that it want to hear some data on every other device on the same network, the network 1, the data will flow out to all port, but router A will judge that the shouting of a device should be limited to its network, not traversing the network. So the shout of device A will only reach to this device. We can say device C, but not B. I hope that you are getting. Packet switching. Routers are like switches because they essentially switch packet between network. Communication between network. Router allow communication between network connected to it. Actually, it's a very good thing. What is packet switching? Actually, there's another form of switching. I'm not currently recalling it. I'm going to note it here, and we will look this in a future. Path selection. Select the best path to reach a network is called a route selection. It's a very good thing to note. Path filtering. Dropping of packets is known as path filtering. So there's nothing much. Now time to switch to next networking types. Network are transferred into depending on size, expense, security purpose, and other parameter. Only two important network classifications are given: local area network, wide area network. This is the word. LAN is usually has high transfer rate. Ethernet standard is the most commonly used in local area network. Ethernet is so common that it is almost synonymous with the local area network today. Wide area network, when an area spans over a city, multiple cities, country, or even across the world, then it is considered to be a wide area network. Inter-networking models. They are used to different ways of networking, as the computer were not compatible with each other, means one cannot share the data. The problem associated with proprietary software, that they are designed to run on a specific platform and is not able to run on another. The same problem exists in earlier days of networking. So in order to gain some inter-vendor compatibility, it's a very good word. OSI. We have to remember the year of the OSI, 1984. Actually, this was one of the question hinted in the CCNA exam. And the TCP IP model. It is essentially the same as OSI model. Actually, the TCP IP model is much lighter and easier to understand than the OSI model. And it is considered to be succeeded in 1985, right after the So here we finish our second chapter. Now time for OSI reference model. And here is our 7 layers of OSI model. What I'm gonna do is here is an application layer. The best thing about application layer is services that an application requires. Next is presentation layer. Data translation and encoding. Give me a 1 minute break so I can make the copy and pasting much easier. Next is session layer. Instances of application. Keep the data from each section. Transport layer. End-to-end transfer of data. Next is network layer. Logical addressing. I hate it. And I have to write it. Network layer, what we do is network addressing. And we also do something called path determination. Actually, we got a data moving in a data moving. It might be bugging you that my face overlaps the or what I can do is minimize this, and I'm sure that it might not be bugging as much as it was before. Now switches function at this layer. Physical layer. Physical transmission medium itself. It may include wire, optical cables, fibers, etc. Data encapsulation. Data being sent from one layer to next over layer is called PDU. It's a very good question, often asked by interviewer, that what does a PDU mean? The PDU means the data, a special name given to the data when the data is transversing from one layer to another. The encapsulation is the adding of a header in front of the data. Encapsulation. Adding up of. Process of examining and removing of the additional data that we added during the encapsulation is known as decapsulation. And this is the word that I was looking for. All people seem to need data processing. For those who are wondering why I'm using VS Code in order to write such a basic thing, actually I am writing a markdown file, which if I can paste Ctrl Shift and V, and here we can see that it is going to be formatted in a beautiful way, which I call the VS Code way, or the best formatting way available till today. Continuing the process. And now time for next chapter, the TCP IP model. TCP IP model. So there are total of 7 layers. Let me name the layers first. And as you can see, the different things are neatly organized now. What we can also see is, in order to highlight the important word PDU, I just have to do a backtick and it will refer as the highlighted key term, protocol data unit, as I can see here. Suppose I want to highlight the encapsulation, decapsulation, the output will seem like this. Encapsulation is the adding of here, the process of examining decapsulation. That's why I'm using the markdown file. Actually, it's a very good thing. If you master the markdown file, the notes taking for the life will be free of any proprietary closed source app, because markdown file is the widely used format for writing the manuals in the open source community. It's a great thing or a great skill to learn. But this video is not about that. So coming to the application layer. Application layer. Here we are going OSI models, application, presentation, and session layer. We have to make another section, protocols. इसमें पहला है टेलनेट. Actually, telnet in very simple terms is a protocol that enables the control of a different device using another different device with the means of communication and using network. For example, if I use my phone to run a command on my Arch PC, by the way I use Arch, so if such communication happens between them, then it might be possible that I am using the telnet protocol. Actually, the telnet protocol got expired, redundant, obsolete, and now the SSH is running or replacing it. And we are actually in the version SSH version 2 as per our CCNA syllabus. Access the resource of a remote host. This is the best word term to define what the telnet is. Second protocol is HTTP, and I'm not going to bother writing the full form of HTTP. What it used to transfer web pages and such resource from web server to client or HTTP server. To transfer web pages, HTTP. Actually, the HTTP is replaced by HTTPS. FTP, the file transfer protocol. It's a very nice thing. Daemon are basically the services that runs alongside the main application or sometimes without the application in the background in order to facilitate or hear the connection so the intended application works as expected. So when in a layman term, when we talk about application, we are just talking about the graphical interface that we are seeing on the screen. But the application is much more than that. The application requires multiple processes to happen. If you're on Windows or if you're on Mac OS, you can see the system monitor or the task manager. Here you can see the application list that are currently running as well as a tab of app services. These services are the protocols, or what we in Linux world we say daemons, which runs alongside the application or sometimes without application in order to make the communication work. So FTP, Telnet, SSH requires a daemon to run in background in order to facilitate the communication. Now we have simple mail transfer protocol, transferring file between two hosts. Actually, I don't want to write it here, but for sake of completion of the notes, I must have to write here. SMTP. Post Office Protocol 3, POP3. email client to send emails. You are using SMTP. Okay. Good thing to mention that the client receiving the email does not use SMTP, it uses POP3. TFTP. Another interviewer's favorite question: why TFTP is not preferred as widely, but it is preferred while sharing a boot image from one device to another, because it is the stripped down version of FTP. This is a very nice and pretty funky word, stripped down version of FTP. The main thing that you have to remember that it doesn't support authentication. DNS. Actually, after the video, or if you are just bored of the video, you can now search some DNS memes in order to entertain yourself. DNS helps map a names to an IP address of the host where the site resides. What's an IP address? Certainly we are going to see it's something has to do with the layer 3. Now we have DHCP, Dynamic Host Control Protocol. It is the protocol that assigns an IP address to a device, and the DNS translates that IP address to a human readable URL. For example, www.cisco.com. It's an human readable URL, but if we show the IP address, let me Google it for you. IP address for www.cisco.com. Actually, I have to go this way by using IP address for website. Domain to IP lookup. Actually, we are doing the reverse DNS search. We are entering the IP address, we are entering the URL, and we are getting an IP address that you can see that it is not an human readable format, at least not an human understandable or rememberable format, that is 23.56 or 210.155. It is the domain name of .cisco.com. Wow. Coming back to our study, we just learned DNS. Now we are going to learn DHCP. So basically, what DHCP does is the automation of assigning of IP addresses in large multi-host network. Now we are back to a different layer, transport layer. Transport layer is functions same as OSI layers transport, concerned with end-to-end transportation of data, set up a logical connection between the host. Same as OSI. TCP, Transmission Control Protocol. Connection oriented reliable protocol, windowing to control order delivery in data segment. Actually, it's a best definition. Connection oriented. Connection oriented means it actually makes sure that I am talking with you. Just like before setting up this setup, I actually run a test video in order to check whether everything is working fine or not. And that is the method of checking the connection orientation of between this video stream and me. Reliable. What does reliable means? Reliable means someone that has trust to. For example, I feel that my computer has become more reliable as I am getting and giving it time in order to configure the polish the default configuration in order to suit my needs. How does TCP ensures reliability? In the time in the data transfer, actually it checks and ensures that each and every packet of the data, actually the big data is broken into smaller chunks, so the every chunk reaches to the intended destination is checked by the TCP. What is the word windowing here means? Windowing means to windowing means basically stacking of the smaller packets in order to push it at a single instance. So what we use that windowing to control the flow. Suppose we say we have packets of 5 that we are carrying in a single hand, and this is the window. If I want to increase the flow, I might carry 6 or 7 packets at once, and if I want to reduce the flow, I can only carry 3 packets at once. And this is the system of flexible packaging the multiple packets together is known as windowing. So in order to control the flow, the TCP uses windowing. And what is the ordered delivery? Ordered means that the every packet is numbered, just like the list that I am numbering here 1, 2, 3, 4 and 5. Actually, in this particular context, this numbering doesn't mean anything. But suppose we want to get this website and some paragraphs are posted here and there. Suppose this paragraph is here, this is here, so then it will make no sense. So actually the ordering of the data is as important as receiving the data, and these things are taken care by the TCP protocol. Finally, the UDP. Simply transfers the data. It actually because it doesn't have the burden of connection oriented or reliability, windowing system or an order delivery, the UDP is also known as the fastest protocol in order to transfer the data. But the data may be unordered, maybe it will drop in between, maybe the received data might get corrupted in its pathway. It doesn't use window, it just push all its data at a single stream as much fast as a computer can handle or the network can handle. Actually, in the UDP stream, what we're going to see is bottlenecks. The bottleneck is a point where, while being everything as its fullest, the only single loose chain or the weakest chain in a link or the weakest link in a chain that breaks the whole system. If you recall that we have already learnt a session layer that keeps the data from each session separate. If the IP address of a device, for example, we just seen that the cisco.com is same, then how the cisco.com is being served to the multiple peoples at once? Or we can browse the same cisco.com using multiple tabs or the multiple browsers at once. How the process of accessing the cisco.com is separated? Actually, the separation is happened using the port number. So let's see what we can extract from the port number. Combination of IP address, protocol and port number forms a socket at both receiving and sending hot, and this socket is unique and application and send and receive data from multiple hot. So actually we are not seeing a definition of port number here. So basically port number is a value that ranges from 0 to 65,535 if I recalling it correctly, and the values between 0 to 65,535 is also divided into multiple not multiple, in actually three major categories: well known, registered and ephemeral ports, depending on their use case and context. Here are some well-known port number which comes between 0 to 1024, 1024. We actually have to remember some well-known port number. Wow, we have to now study three-way handshake. It's also an interviewer favorite question. What's a three-way handshake? Setting up of a virtual circuit between source and destination. Sometimes the interviewer may get interested in knowing the sizes of the port number, destination, sequence number, acknowledgement number, bits, etc. So you must have to at least try to remember it, not actually remember it. If you look on these values repeatedly, it automatically get covered in the memory. Actually, there's also another thing called four-way handshake. So let me copy and paste it. The three-way handshake is done when we want to establish a connection. But when we want to finish the connection, all talking in context of TCP, transmission control protocol, if we want to disconnect from someone, or when this session establishment has been finished, it got finished using a four-way handshake. The three-way handshake uses a SYN and ACK flag in the code-based section of the header. SYN stands for synchronization. Well, ACK stands for acknowledgement. So first the source sent a SYN flag, then destination sends a SYN and ACK flag, and finally the source sends an SYN and ACK flag. Here we are seeing that the source responds back with only one ACK bit set. After this the data flow can commence. SYN ACK MTU, maximum transmission unit. Limitation set by protocols to send data in a single EDU is called MTU, which is also known as maximum transmission unit. Flow control. I think I have already told you about the flow control. The sending of data in groups of segment and the adjustment of the size of group depending on what we need. If we need to increase the speed of data, we just as I've just told you that we can use, instead of sending 5 packets at once, we can send 6 or 7 packets, which ultimately increases the speed of the network. And if we want to slow down, we can send 3 or 2 packets at once, and this is called the flow control. I'm not going to write the flow control, or should I? Actually, we have to introduce the word sliding window. The window that automatically adjusts itself is called the sliding window. We can add a bracket here and add the following words here: sending data in groups of segments. Groups of adjustable segments. Order, delivery, connection termination, and here comes our 4-way handshake. Fin and flag. To close the session, fin and flags are used. Actually, we got a few more things about TCP. The TCP has a higher overhead with a larger header and acknowledgement. The source also holds data till it receives acknowledgement. And this creates delay. I once was asked by an interviewer why and in which situation we have to use UDP instead of TCP. I should have answered that in this situation or the application that deals with voice and video, which requires fast transport and takes care of the reliability themselves at application layer, must use or need to use UDP. Actually, it doesn't come with all the bells and whistles like connection oriented, reliability, sliding window, etc. But it's fast, and the being fast is such an advantage that every other feature of TCP is not still able to overcome the need or the gap left in communication by UDP. Now we came to internet layer. I think it was the internet layer that was just a renamed version of or the combination of two layers. Network layer. No, it was just a rename of network layer. Where did the... Here comes the sun. Internet layer. Corresponds to network layer of OSI model. Finally, the internet protocol IP layer. PD is called a packet. Actually, we were discussing about the PDU. Now the time has come to add few details over PDU. So when talking about PDU, actually we have to worry about the last four layer, or sometimes in the reverse context you can say the first four layer of OSI model: physical, data, network and transport. And the mnemonic that I used to remember the different PDUs is B, let me put the caps on, B, F, P, S. B stands for bits, F stands for frames, P stands for packets, and S stands for segments. So the first layer or the last layer, physical layer, the PDU here is known as bits because the data is its raw form, the electrical signal, and the electrical signal represents the bits in a computer network. The frames, the data link layer, the layer in which devices like switch, hub, hub, switch, bridge work, is known as data link layer, and all these devices deal with PDU known as frames. Finally, the network layer, the every packet or PDU is termed as packet. And finally, in transport layer, it is then termed as segments. These are nothing but the same data encapsulated and decapsulated as per the needs and requirements. Actually, we don't have to study everything in detail, but as we are going through it, let me fast forward it and just recall you what the main thing that we need to worry. So the version, actually we have two kinds of IP addressing scheme or the IP versions. First is 4 and other is 6. Actually the 4 is so much strictly configured in our routes that even despite the coming of IP version 6, the IP version 4 is so prominent and stuck in our routes that even after the coming of much required IP version 6, we are still stuck with version 4. Header length, specifies the size of header itself. Minimum is 20 and there is no maximum mentioned. DS field, DS stands for differentiated service. It's the differentiation of how the packet should be treated when passing from one network or one device to other. It is a part of quality of service because not every packets are equal. Some requires a special treatment and care, while the other can be lost and doesn't cost a dime. So actually the differentiation between the different packets is known as, and which is done using DS field. Total size defines the size of packet. Total length, the size of packet. Identification, the when IP receives segment from TCP or UDP, it may change to break segment called fragments. Flags used for fragmentation purpose. Fragment offset identifies the fragment number used by host to reassemble the packets. We know that we have the TCP orders the packets, and all this ordering is done using this fragment offset. TTL, time to leave. Time to leave, what does it mean, time to leave? Actually it's a defined period of life of an packet, actually defined by the originating device or the device that is in between sending the packet. Each router that packet passes through reduce the TTL by 1. Actually we have to set a default value of TTL and it is usually 15. So a packet can traverse up to 15 hops and after that it expires. Sometimes the TTL got modified in midway depending on the context of network. Finally there's an field that specifies which protocol we are using. Then there is an header checksum. What is checksum? A checksum is a special fingerprint or a special number that or a hash generated which is used to verify the authenticity of the packet. So if there is some modification in packet, the checksum usually used to change, and this identifies that there might be some tampering with packet or the packet may be corrupted. Now time for routing protocols. Router 1 knew that since they ICMP, time exceeded, echo reply, network access layer. Okay. This isn't much, but just a glimpse that we are going to study routing protocol in our upcoming chapters. Actually, the routing protocol is the protocol that defines how the IP addresses or the set of IP addresses are handled, how they are being sent from one address to another in order to locate a device, or how the addressing scheme of a network works. Next is another protocol, ICMP, Internet Control Message Protocol. It is a management protocol and which we can add to our protocol section. Where does it goes? Management and messaging service for IP. Destination network unreachable. Finally, we are talking about network access layer. Corresponds with the data link and physical layer. A network access layer video is called frame. Time to move to next chapter, Ethernet technologies and cabling. But before that, I want a small break. So thank you for staying up at late at night and being with me. We already studied for 1 hour and 5 minutes. So time for a break.